We are back again and we are still on finding the solution of a differential equation. That is what we have as our heading. Now here, everything we are doing is about ODE, ordinary differential equation, which means the unknown variable in this question is just one, which is y, and the independent variable is also one, that is x. So this is all about what we are coming to do. Now in this case, they are asking us to find the solution of a particular differential equation, and you can see that this is ODE. So here we need to check the method we can use to solve the question. If the question is so easy that we can integrate both sides to get the answer, then we are good to go. But in a situation where we have the unknown variable mixed with the independent variable, then it means we need to use certain methods to solve the solution. So here, these are the methods we are talking about. We have the separable, exact, integrating factor, and homogeneous and linear first order. So we are coming to take them one after the other. But in this video, we will talk about this. Please, if you want to get all of them, or if you want to get more of this, make sure you will subscribe to this channel and you will get everything. All right, now let's look at the first question, the one we have on the board. So we are saying that with separable, when a differential equation is given to us, if we can write it in this form, px dx plus qy dy is equal to 0, then we can say that that differential equation, we can use the separable method to solve it, which means that you can see that we have the function of x separated from the function of y, right? So if we can get something like that, or if we can also write it in this form, maybe negative, then we can say that we can use the separable method to solve it. So indeed, let's look at what we have on the board and see whether it will fall under the separable. If it falls under the separable, here what we will do is that we want to find the solution. So we will integrate both sides to get the solution. Now let's see the problem on the board. So we are under separable. It means separable method. So we are using the separable method to see whether we can use it to solve this question. All right, now let's see. So we have this. Is this question separable? Yes, I can see that it is separable because here the denominator is in terms of y only, and here the numerator is in terms of x only. So if that is the case, I have my dx here, my dy here. I can what? Cross multiply to get it. So let's see. This will multiply this. I'll get 3 brackets y minus 1 squared dy, and is equal to 2 plus sine x dx. So if you compare this one to them, you can see that this resembles this. So it means we can use the method or the separable method to solve it. All right, so let's find the solution. Now we are saying that if you have this, how to get the solution is you have to integrate both sides. So I will integrate here, I will integrate here. Now I will integrate here with respect to y. I will also integrate here with respect to x, right? So after that, what I will do is that, okay, I have something like this. Maybe somebody can choose to what, expand this before integrating each term over here. It is acceptable. All of us will get the same answer. Or as for me, I can see that if I add 1 to it and divide, it is still the same. So I will add 1 to it and divide. That is y minus 1. Here will be 3 and divide. Integration, you will add and divide whatever power you will get, and it should be equal to, I'm supposed to bring constant here because this is indefinite integral, but this is the unknown variable. So I will hold that and bring the constant to the independent, or where the independent variable is. So I will also integrate this. I will get 2x. If you integrate this is trig identities. So if you don't know, go and revise or just watch some 2 or 3 videos about it and you will get it. All right, so here they are saying that if you differentiate cos, you will get negative sign. If you integrate sign, that means you will get negative cos. So here I will get negative cos x plus constant because it is indefinite. We don't have limits here. All right, so the next thing I will do is that I will simplify. I will get y minus 1 cube, right? And it's equal to 2x minus cos x plus c. So what I will do again is that I want to find y because I can find y here. So I will find the cubic root on both sides. So I will multiply here 2 by 1 over 3. So this will cancel this. I'll get y minus 1 is equal to 2x minus cos x plus c, 1 over 3. So I will send this one to the other side and I'll get y is equal to 2x minus cos x plus c. And here is 1 over 3 plus 1. So this is the solution they are talking about. This is the general solution because you can see that we have c in it. They can add an initial value problem to that. That is the initial condition for us to find the particular solution. So let's assume that we have the initial condition y of 0 and is equal to 1, something like this. Y of 0 is equal to 1. So if we have something like that here per the IVP, that is the initial value problem, we can say that our x is equal to 0 because we always write it in this form. So this is y. Our y is 1. Our x here is equal to 0. So let's do the substitution to find the particular solution. So y is 1. I will substitute 1 here, bracket 2, bracket 0, minus here cos 0 plus constant c. And that is what I'm looking for. 1 over 3 plus this one. Now, this will give me 0, right? I'll bring this one to this side. So that one will give me 0. So I'll get 0 is equal to, this is 0. This will give me negative 1 because cos 0 is 1 plus c and raised power 1 over 3. So I can say that, okay, let me find the cube on both sides. So 0 times 0 times 0, it will give me 0. It's equal to here, it will be negative 1 plus c. So I can say that my c will be equal to positive 1. Then, because I'm looking for a particular solution, so I will what? I will substitute the one here, and that one will give me the particular solution. All right. So this is all about using the separable method to find the solution of a differential equation. Let's look at another example. So another example, I have cos y dx minus sine y dy and is equal to 0. So still we need to check whether we can get something like this. So if I can get something like this in this equation, then it means that I can use the separable method to solve it. So let's see. I have this function, which is what? A y function. So it means that if I divide through by that, this one will be part of this, right? So if I do that, I will get dy minus here will be sine y over cos y dy, and it should be equal to, if we divide still you will get 0. So this is true. Now, because I want to find the solution, so I'll take this one to the other side, meaning I will get dy is equal to sine y over cos y dy. Now, we are saying that if we are using this method, and if we want to get the solution, we will integrate both sides to get the answer or to get the solution. So in this case, I will integrate here, I will integrate here. Now, sorry, here is supposed to be x. Here too supposed to be x, and this is y rather. All right, so I will integrate here. If I integrate here, I will get x plus c. This is independent variable, so I need to add the unknown constant to it. Now I have to integrate this. So what I will do is that here it is in terms of trig identities. So let's see whether substitution method will work over here. So with the substitution method, I will say let u be equal to what I have here, cos y. Then let me differentiate it. So I will differentiate u with respect to y. I'll get, so that one will give me negative sine y, right? Now I want to find dy because there is dy here. So dy will be equal to negative du over negative over sine y. what I did over here is I interchanged this and this. So if you do that, negative of this will come here and the y will go there. That is what I've done over here. Now after that, let's come and do the substitution. So I'll get integral sine y over, I said let u be equal to this, so here will be u. Then dy, what is my dy? I said from here, dy is negative du over sine this. So this will cancel this, right? Now after that, I'll bring the negative out. So I'll get x plus c is equal to negative bracket integral 1 over u du. We are saying that if we differentiate ln x, you will get 1 over x. So if we are reversing it, then it means you will get this. I am reversing this, so it automatically I will get ln what? Ln u. So I will get x plus c is equal to negative ln u. Here, the condition is that because we are looking for the solution for the unknown variable, make sure that the coefficient of the unknown is positive. So that means I will divide through by -1. So the negative will come to this side. I will get negative bracket x plus c, and it's equal to ln u, right? So what is u? Because from the question, we don't have any u. Now, our u, we said u is equal to cos y. So I will bring that one there. I will get negative x plus c, sorry, plus c is equal to ln cos y. We are looking for the solution. That means I want to make y the subject for this equation. So what I will do is that I will find anti-log on both sides. This is natural log. So if I find anti-log, I will use e, which is e raised power this, e raised power this. Then this is what I will get. We are also saying that if you have e raised power ln x, then it's equal to x. And that means if you have something like this, whatever we have here will be the answer. I have this. So that means what I have here will be my answer, which is cos y will be my answer. So in this case, I will get cos y is equal to, here too, we are saying if you have something like this, which is e raised power minus bracket x plus c. Okay, so I can expand the bracket. So I will get e raised power minus x minus c by using the law of indices. So I can split this in this form, e raised power minus x multiplying e raised power minus c. And we are saying that this is a constant raised power, a constant. So a constant raised power, a constant, automatically we will get a constant. So I will use k to represent this, which means I will get e raised power negative x multiplying k, right? So it means I will get k multiplying e raised power minus x. Again, I want to find y. So what I will do is that, okay, I will find cos inverse on both sides. So I will get y will be equal to cos inverse of k e raised power x. Likewise, this is our general solution. So you can see that I have the unknown constant over here, which is k. So this one gives us the solution, and it is the general solution. So assuming that we have the initial value problem attached to this question, that one will help us to find um, the particular solution. So me too, I have a question for you. Just try your hand on that one, and after that, send your answer through the comment section to us. So you too, this is your challenge. Try this. Okay, so I have y prime is equal to x cubed y minus y all over y raised power 4 minus y squared plus y. And here there is an initial condition given. So if you if we are done with the solution, just send it to us through the comment section. And in our next video, we will use the method of exact to also solve another differential equation. Thank you for watching us.